Dear students, today we are going to discuss some sums related to wave. First question is a stone dropped from the top of a tower of height 300 meter high splashes into the water of a pond near the base of the tower. When is the splash heard at the top? Given that the speed of sound in air is 340 meter per second, the solution is here h that is equals to height, that is also distance covered, that is equals to 300 meter. G, that is acceleration due to gravity, is 9.8 meter per second square, and velocity is 340 meter per second. So if T1 equals to time taken by stone to strike the surface of water in the pond, then from the second equation of motion, which is s equals to ut plus half at square, here s is equals to h ut1 and half, in place of a g we are writing half gt1 square, since a equals to g equals to acceleration due to gravity, and here initial velocity equals to u, that is equals to 0, as it starts from rest. So whenever something moving object starts from rest, u will be, initial velocity will be 0. So 300 equals to 0 into t1 plus half into 9.8 into t1 square. So 300 equals to, this is 0, so this we are removing, and 9.8 is divided by 2, so we get 4.9 into t1 square. And so t1 square equals to 300 by 4.9. Decimal is removed, and then we get here 3000 by 49. Now here square is removed, and then t1 is equal to square root under. This total comes under square root, and it becomes 30 into 10 into 10 by 7 into 7. So 10 by 7 is coming out, and square root under 30 is left. Square root of 30, that means the square root of 30 is 5.47. So T1 equals to 10 by 7 into 5.47, that is equals to 4.7087, that is equals to, after dividing you get 7.82 seconds. So time taken by sound to reach the top of the tower, that is equals to T2, that is distance by speed. So h is the distance, height, h by v, and that is equals to 300 by 340, and that is equals to 0.88 second. So total time, because one time is striking down the pond, that means, and then second sound is going up to the tower. So total time, that is after which splash of sound is heard, is t1 plus t2. So 7.82 plus 0.88 is equals to 8.70 second. This is the answer. Second question is, a string of mass 2.50 kg is under a tension of 200 Newton. The length of the stretched string is 20.0 meter. If the transverse jerk is struck at one end of the string, how long does the disturbance take to reach the other end? Solution is, here we have m, that is mass of a string, that is equals to 2.50 kg. T, that is tension in the string, that's 200 Newton, which is the force. Tension is produced due to force, and that's why it is 200 Newton. And length of the stretched string due to the tension, that is small l, that is 20.0 l. Now mass per unit length equals to small m, that is equals to mass of the string divided by length of the string, that is equals to 2.5 by 20.0, and then after removing the decimal we get 25 by 200, and so it is being cancelled, that is equals to 1 by 8, and by dividing we get 0.125 kg per meter. Now velocity v equals to square root under tension by mass per unit length. Tension, that is equals to square root under capital T by small m, and therefore v equals to square root under 200 by 0.125, and after removing the decimal we get square root under 200 into 1000 by 125. And now while 25 8 are 200, 25 5 are 125, and 1000 is divided by 5, then we get here 200. So this 208 by after multiplying we get 1600. So a square root under 1600, and that's equals to 40 meter per second. This is the velocity. Therefore, time taken by disturbance to reach the other end, that is equals to t, that is equals to small l by v, that is distance by speed, and so t equals to distance by velocity equals to 20 divided 40, that is equals to 0.5 second. This is the answer. Thank you. If you like, please share and subscribe.